For decades, we've looked to the stars and wondered, is anyone out there listening? But perhaps a more important question is, are we listening hard enough? The search for intelligent life beyond Earth has taken many forms, but none are more iconic than the work being done at the SETI Institute, the search for extraterrestrial intelligence. This isn't science fiction. It's not a hobby for stargazers. It's real, rigorous, scientific work led by astrophysicists and engineers with one goal: to detect a signal. Just one. A deliberate, non-random transmission from a distant intelligence. And how do we try to catch such a signal? With radio waves, energy that travels at the speed of light, capable of crossing vast interstellar distances. Radio is a natural choice. It's not only a method we already use for communication here on Earth, but it's also less likely to be absorbed or scattered by cosmic dust. It travels cleanly through space and is detectable with relatively simple instruments. At the heart of SETI is Dr. Seth Shostak, the Institute's senior astronomer. For most of his life, he has scanned the skies using massive radio telescopes, listening for signs of alien technology. What he's hoping to detect isn't a voice or music. It's a narrow-band signal, something so precise and organized that it couldn't be produced by any natural process. To explain what they're listening for, imagine a musical flute tone played in front of a roaring waterfall. The waterfall is space, filled with white noise from stars, pulsars, quasars, and other cosmic phenomena. But if someone is deliberately transmitting, their signal would stand out. It would be clean, steady, unmistakably artificial. A pure tone, a spike of energy confined to a very tight frequency range. And over the past 40 years, that's exactly what SETI has been listening for. But here's the sobering truth. We've heard nothing. No clear signals, no alien broadcasts, no cosmic hello. Yet scientists remain undeterred. Because silence doesn't mean absence, it might mean we're not listening in the right way, or in the right direction, or at the right time. After all, even the speed of light has its limits. If an alien civilization on the far side of the galaxy sent out a message today, it might take 100,000 years to reach us. Or worse, maybe they sent it 100,000 years ago, and it's only just arriving. That's the frustrating beauty of space. Distance is both the invitation and the obstacle. So where do we focus our efforts? One key location is Arecibo, Puerto Rico, once home to one of the largest and most sensitive radio dishes on Earth before its unfortunate collapse in 2020. From 1997 onward, Arecibo hosted Project Phoenix, which scanned thousands of nearby stars, up to 200 light-years from Earth, for radio signals. That's like searching your immediate neighborhood for someone shouting across the galaxy. It's a start, but only a fraction of what needs to be done. The universe is flooded with radio waves from all kinds of natural sources. But SETI's goal is to detect a signal that shows signs of intention, of engineering, something made by a mind. But what if aliens aren't using radio waves at all? What if they've evolved far past that and instead use optical lasers to communicate? Beams of intense light that can carry vast amounts of data across space. In recent years, some scientists have begun turning their attention to optical SETI, scanning the sky not for sounds, but for light. One such scientist is Dan Wertheimer, an optical SETI pioneer from the University of California, Berkeley. His team has been searching for brief flashes of laser light from distant stars, a blink lasting just a billionth of a second, but powerful enough to outshine the star itself. That's the kind of signal only intelligent life could send. A Morse code-like pulse, perhaps. On, off, on, off. A message encoded in bursts of light. Lasers have some advantages over radio waves. They can be focused with extreme precision, aimed directly at a target with little loss. That means the aliens could send vast libraries of information, data on their culture, music, mathematics, perhaps even a cosmic Wikipedia, if only we knew how to read it. But detecting those signals isn't easy. In a billionth of a second, a telescope might receive just 10 photons, tiny packets of light, from a laser pulse. That's rare. In fact, it's vanishingly rare from natural sources. So far, Wertheimer's team has scanned over 10,000 stars. But like the radio surveys, they've found nothing conclusive. No flashes, no messages. Still, they keep watching. Because technology is evolving. Telescopes are becoming more powerful, sensors more sensitive, and as we begin surveying millions more stars, the odds improve. After all, even on Earth, life took billions of years to evolve into intelligent beings capable of communication. So if alien civilizations are out there, their lifespans, priorities, or technologies may be completely alien to us. Maybe they're not listening. Maybe they're deliberately hiding. Or maybe we're just looking at the wrong stars. But the search continues, quietly, patiently. And sometimes, just sometimes, we find something we can't explain. Take the WOW signal, for instance, detected on August 15, 1977, by a radio telescope at Ohio State University. It was a 72-second spike of radio energy, narrow band, seemingly artificial, coming from the direction of the constellation Sagittarius. It was so unusual that the astronomer who first got the printout scribbled one word beside it: "Wow." Since then, despite repeated attempts to detect it again, the signal has never repeated. But to this day, it remains one of the most mysterious and potentially promising radio signals ever received. No natural explanation has fully accounted for it. Was it aliens? We may never know. But it reminded the world, and the scientific community, that the universe can still surprise us. The sky remains full of mystery, waiting for us to unlock it. And here at Infinity Beyond, we believe the question isn't if we'll make contact, it's when.